In 2004, a group of 12 guys from the American Midwest pooled about $1,500 each, built a Jeep Cherokee in a couple of weeks, tested it exactly once, and entered the Baja 1000, the most dangerous off-road race on the planet. They were competing against $500,000 trophy trucks with 36 inches of suspension travel, 800 horsepower engines, and helicopter support crews. The Cherokee had 10 inches of travel and a stock 6-cylinder engine. They won their class, and nobody who knew the XJ was surprised. The story of the Jeep Cherokee XJ in desert racing is really the story of an accountant's compromise that turned into a weapon. In the late 1970s, American Motors Corporation was dying. AMC was the smallest of the big American automakers, and the energy crisis was strangling every company that sold large, fuel-hungry trucks. Jeep's lineup at the time was built around the full-size Cherokee XJ, a body-on-frame beast that drank gasoline like it was free and weighed about as much as a small apartment. Federal fuel economy mandates were coming down hard. The Energy Policy and Conservation Act of 1975 demanded that every four-wheel drive vehicle in America average 15 miles per gallon by 1981. The SJ couldn't sniff that number on its best day rolling downhill with a tailwind. AMC had tried to survive with smaller passenger cars like the Pacer, which sported styling so controversial that buyers flat-out refused to go near it. The company was hemorrhaging cash. Dealerships were closing across the country. The boardroom didn't just smell like desperation, it reeked of it. MC needed a miracle. Instead, they got something better. They got a French engineer. In 1979, Renault bought a 22% stake in AMC for $150 million and sent over a man named Francois Castang to run product development. Castang wasn't some corporate suit shuffling papers between meetings. He'd been the technical director of Renault Sport. Before coming to Detroit, he'd spent years developing race engines for the 24 Hours of Le Mans. This was a man who understood at a molecular level what lightweight structures could survive when you pushed them past every reasonable limit. Now he was in Toledo, Ohio, staring at a lineup of overweight trucks and a company that couldn't afford to fail one more time, and he had a mandate to fix everything. His solution was radical enough to terrify the Jeep old guard. Build a Jeep that wasn't really built like a Jeep at all. The existing philosophy in the four-wheel drive world was simple, well-proven, and decades old. You take a heavy steel frame, bolt a body on top of it, hang solid axles underneath, and power the whole thing with the biggest engine that physically fits between the frame rails. Every truck, every SUV, every serious off-road vehicle on the American market followed this formula. The Ford Bronco did it. The Chevy Blazer did it. The International Scout did it. It worked. It was proven. It was also enormously heavy and hopelessly inefficient. Castang threw the whole formula out. He wanted unibody construction, one piece. Body and frame integrated into a single monocoque structure, like a racing car, not like a truck. The old-school Jeep guys at AMC thought he was out of his mind. Dealers sent worried letters to headquarters. Enthusiasts wrote angry columns in off-road magazines. A unibody Jeep. The very phrase sounded like a punchline. A unibody four-wheel drive vehicle sounded like a contradiction in terms. Unibodies were for sedans and economy cars, things that lived on pavement and never touched dirt. You hit a rock hard enough with a unibody and the whole structure flexes. There's no separate frame underneath to absorb the punishment. The chassis is the body is the chassis. Break one, you break both. But Castang had a counter-argument, and it came from his racing background. Lightweight structures survive abuse when they're designed to distribute loads across the entire structure rather than concentrating them at mounting points. The Range Rover used a similar philosophy. The Mercedes G-Class used coil-sprung solid axles in a rigid structure, And neither of those vehicles was designed by a man who'd been tuning Le Mans engines for a living. The plan started with weight. The XJ's Unibody would use over 3,200 welds to create a single, integrated structure that was rigid enough to handle serious off-road abuse while being 1,200 pounds lighter than the Cherokee it replaced. Dick Teague, AMC's design chief, penned the exterior with a European-influenced clarity of line that would age so remarkably well that Automobile Magazine's Robert Cumberford later called it possibly the best SUV shape of all time, the paradigmatic model to which other designers have since aspired. Roy Lunn, a brilliant suspension engineer poached from Ford, designed a front suspension called Quadra Link that used 4 trailing control arms and a panhard rod to locate the solid front axle, coil springs up front, leaf springs out back. Simple, proven, but wrapped in a package that nobody believed could work until it did. To prove the concept wasn't suicidal, AMC sent 2 XJ prototypes to compete in the 1983 Paris-Dakar Rally, arguably the most brutal off-road race in the world at the time. Both finished. They didn't win. That wasn't the point. The point was that a unibody four-wheel drive vehicle had survived the Sahara Desert without tearing itself in half. The critics went quiet, not convinced, but quiet. 1,200 pounds lighter. That's the number that changes everything. The new XJ kept 90% of the old Cherokee's interior volume while being 31 inches shorter, 6 inches narrower, and 4 inches lower. Smaller in every external dimension, but nearly identical inside. Ground clearance actually improved. Approach, departure, and breakover angles all got better. And all that missing mass changed the physics of everything the vehicle could do. The suspension worked better because it had less weight to control. The brakes worked better because they had less momentum to fight. The steering felt sharper. The fuel economy jumped enough to satisfy the federal mandates that had started this entire desperate project. The XJ debuted for the 1984 model year and swept the 4x4 of the Year awards from 3 major off-road publications. That simultaneous sweep had never happened before with any vehicle. But AMC also did something nobody in the American compact SUV market had tried. They offered a 4-door variant. 2 doors was standard for the class. The S10 Blazer had 2 doors. The Bronco 2 had 2 doors. 4 doors seemed risky. Buyers overwhelmingly chose the 4-door. The Cherokee was an immediate commercial success, and AMC posted its best sales numbers in years. Then came the engine that defined the platform for the next 2 decades. In 1987, AMC introduced the 4.0-liter inline-six. 242 cubic inches of displacement, cast iron block, cast iron cylinder head, overhead valves actuated by hydraulic lifters, push rods, and rocker arms. No overhead camshaft, no variable valve timing, no direct injection, no turbocharger, nothing remotely fancy. The high-output version eventually produced 190 horsepower and 225 pound-feet of torque. Those numbers wouldn't embarrass a family sedan, but they wouldn't impress one either. But here's what the spec sheet doesn't capture. The 4.0 was essentially indestructible. The inline-six configuration is inherently balanced for both primary and secondary shaking forces and both primary and secondary rocking couples. It's one of only 2 engine layouts, the other being a V12, that achieves this complete natural balance without counterweights or balance shafts. The engine doesn't vibrate itself apart over hundreds of thousands of miles the way a V6 or V8 does. The cast iron construction in both block and head meant the engine could overheat, recover, and keep running without warping. It could ingest dust and silt and keep turning. 200,000 miles was considered just getting broken in. 300,000 miles was common with basic oil changes. One Cherokee owner documented 500,000 miles on the original engine with nothing beyond standard maintenance. The design traced its DNA back to AMC's Straight Six family from 1964 through the 232 and 258 cubic inch versions that had been powering Jeeps, Wagoneers, and Javelins for decades. By the time the 4.0 went into the XJ, engineers had more than 20 years of evolutionary refinement behind every casting, every bearing surface, and every tolerance. The result was an engine that started every morning, delivered its modest power without complaint, and simply refused to quit. That refusal to quit matters more in the desert than horsepower ever could. Here's the thing about desert racing that people who've never done it don't understand. The Baja Peninsula doesn't care about your top speed or your dyno sheet. It cares about one thing. How long does your truck last? The Baja 1000 is roughly 1,000 miles of the most hostile terrain in North America, silt beds 18 inches deep that swallow vehicles to their axles and coat every air filter, every intake, every radiator with powder finer than talcum. Rock gardens that shatter suspension components like glass. Whoops, those repeating undulations in the desert floor carved by years of truck traffic, and they beat a vehicle apart from the inside out at frequencies that overheat shocks and crack welds. Sudden terrain drops that appear without warning in your headlights. Hidden boulders buried under sand. Cattle wandering across the course at 2 in the morning. The race runs non-stop, start to finish, day and night, and the completion rate in any given year hovers around 50%. Half the vehicles that start don't finish. The purpose-built trophy trucks that dominate the headlines are genuine engineering marvels. Custom space-frame tube chassis designed on computers and welded from chromoly steel. Independent front suspension with over 30 inches of travel. 900 horsepower engines, 40-inch tires mounted on beadlock wheels. These machines can hit jumps at 100 miles per hour and land like they just rolled over a parking lot speed bump. A competitive trophy truck costs anywhere from $500,000 to well over $1 million to build. They travel with helicopter chase crews that can spot obstacles and rival vehicles from the air. Satellite tracking systems relay position data in real time to pit crews stationed strategically across the entire peninsula. Spare parts inventories at each pit would stock a small parts department. A competitive trophy truck racing season, including the vehicle, crew, logistics, and entry fees, can cost $2 to $3 million. A Jeepspeed Cherokee XJ can be built for under $30,000. Some people start with $500. Quick thing. If this is your kind of content, subscribe. We do deep dives like this regularly. Anyway, Jeepspeed was founded in 2001 by Mike Barnett and Clive Skilton. Clive had just returned from the Dakar Rally in Africa with his son Darren, a multi-time Dakar competitor, and came back to Southern California with an idea that was either brilliant or delusional, depending on who you asked. What if you could go desert racing without mortgaging your house? What if you could build a race vehicle from a junkyard, race it on Saturday, and drive it to work on Monday? The Cherokee XJ was the obvious answer. By 2001, XJ production had just ended after 18 years. Nearly 3 million had been built. They were accumulating in junkyards and driveways and backlots across every state in America. You could buy a running one for $1,000, sometimes half that. The 4.0 engine and AX15 5-speed manual were both proven reliable under abuse that would kill most drivetrains. The solid axles, front Dana 30 and rear Chrysler 8.25, were simple, understood by any weekend mechanic, and rebuildable with parts you could find at any auto parts store. The Unibody, which everyone still considered the Cherokee's biggest structural weakness, turned out to provide an advantage nobody had fully appreciated. The whole vehicle weighed about 3,100 pounds. That's light. That's very light for something with solid axles and a cast-iron engine. The Jeepspeed Class 1700 rules were written like a deliberate exercise in competitive restraint. Stock wheelbase, 101.5 inches, give or take 2. Six-cylinder engines only, 250 cubic inches maximum displacement, 33-inch maximum tire diameter, 10 inches of front-wheel travel, 12 inches of rear-wheel travel, one single shock absorber per wheel, no bypass shocks allowed, no coilovers, just basic remote reservoir shocks, a roll cage, upgraded springs, and a mandatory fuel cell for safety. That was it. It was, as the founders intended, basically a stock Jeep with safety equipment and a slightly better suspension tune. Driver skill against the desert, with no amount of money able to buy more travel or more horsepower. The first Jeepspeed race in 2001 attracted names that the off-road world already respected: the Curry family, legendary axle builders from Southern California, Ryan Wallace from Rubicon Express, teams from Skyjacker Suspensions, Tom and Mike Barnett from T&J Performance, who'd go on to build the race engines that powered many championship runs. Together with dozens of Jeep enthusiasts who'd never raced anything before, they finally had a way to go desert racing with their Jeeps. By 2003, 50 race team numbers had been issued and 20 Jeep fields were showing up at every event. By 2008, 35 teams entered the Parker 425 alone. A racing class built around an out-of-production junkyard SUV had become one of the fastest-growing categories in American off-road competition. And then the Cherokees started doing things they had absolutely no business doing. The beauty of the XJ in desert racing isn't raw speed. A Jeepspeed Cherokee tops out around 90 miles per hour, and that's only on a smooth, dry lake bed or a short paved road section. Trophy trucks routinely hit 130. The Cherokee doesn't compete on speed. It competes on strategy. It's narrower, so it threads through tight canyons and rocky sections that wider trucks have to crawl through. It's lighter, so every impact punishes its components less. It doesn't need a $50,000 pit infrastructure spread across the peninsula. And here's the part that drives trophy truck teams genuinely crazy. When the big-dollar trucks start breaking down, the Cherokee is still running. In the 2010 Baja 1000, live satellite trackers showed Jeepspeed Cherokee entries catching up to and physically passing broken-down trophy trucks in the Baja darkness. Andy McMillan and Tim Herbst, heavyweight names in the unlimited class, were sitting on the roadside dealing with mechanical failures while stock engine Cherokees rolled past them through the silt and the rocks. The Jeepspeed cars weren't faster. They didn't need to be faster. They were moving. The trophy trucks weren't. That's the whole game in endurance racing. The vehicle that's still running at mile 800 beats the faster vehicle that broke at mile 600 every single time. And it's not a fluke. It's a pattern that repeats at every major desert race, year after year. So let's get into why, technically, this keeps happening. The 4.0 inline-six has no turbocharger to fail from silt ingestion or heat cycling, no intercooler to clog with the fine alkaline dust that hangs in Baja air like fog after a car passes, no variable valve timing solenoid to malfunction when the oil gets hot and thin, no direct injection system with high-pressure fuel pumps that fail catastrophically. The fuel injection from 1991 onward is multi-port injection, managed by a Mopar engine computer. So simple, it stores fault codes you can read with a bent paperclip bridging two pins on the diagnostic connector. Some Jeepspeed racers bypass the injection system entirely and run carburetors. No computer needed at all, just fuel, air, and spark. If the alternator dies in the middle of the peninsula, a carbureted Cherokee can finish on battery power alone because the ignition and fuel pump are the only things that need electricity. One team at the 2022 Parker race lost their charging wire with 40 miles to go. They shut down every single electrical system except the fuel pump. They crossed the finish line running on 5 volts. Try that with a modern electronically managed 800 horsepower race engine that needs computers to control fuel injection, ignition timing, turbo wastegate position, and variable valve timing simultaneously. The solid axles, the feature that every modern high-performance truck has abandoned in favor of independent front suspension, are the XJ's second hidden advantage. Independent suspension gives more wheel travel. It gives better high-speed stability on smooth surfaces. It also gives you CV joints, upper and lower control arm bushings, ball joints, steering knuckle bearings, and tie rod ends on each side. That's over a dozen potential failure points per axle. A solid axle is a steel tube with shafts running through it, bearings at each end, U-joints connecting to the drive shaft. When it hits a rock, the entire housing moves as one unit. The loads distribute across the whole tube instead of concentrating at a single ball joint or bushing. There's less travel, absolutely, but there are dramatically fewer things that can break, and when something does break on a solid axle, field repair is actually possible. A broken U-joint can be swapped on the side of a Baja road in 30 minutes with a socket set and a hammer. A failed CV joint on an independent suspension truck requires pulling the entire half-shaft assembly. At 2 in the morning, in silt, with no shop, that's the end of your race. The unibody construction, the feature everyone said would be the Cherokee's fatal flaw since 1978, turned out to be its most fascinating characteristic in racing. There is no frame under the XJ, none. Every impact, every landing, every shock load passes through the body panels, the floor, the roof pillars, the entire monocoque shell simultaneously. Over the course of a 1,000-mile desert race, the unibody develops cracks. It always does. The Filarski brothers, one of the most experienced Jeepspeed teams in history, described looking under their race Cherokee at night with the dome lights on. The glow was leaking through dozens of hairline fractures in the floor. It looked, they said, like shining a flashlight through a cheese grater. But those cracks don't end the race. And here's why. A body-on-frame truck that cracks its frame concentrates stress at a single point. That crack propagates with each subsequent impact until the frame fails catastrophically at that location. Game over. A unibody distributes stress differently. When the floor pan cracks in one spot, the load finds another path through the structure, through the roof, through the pillars, through the dozens of other load-carrying members in the monocoque. The cracks spread everywhere, but the structure remains functional because no single crack point carries the full load. Teams reinforce the unibody by tying their roll cage tubes directly into the suspension pickup points, the spring perches, and the shock towers. The cage becomes an internal skeleton, a secondary frame woven through the body. The Cherokee twists, flexes, cracks in 100 places, and keeps going because the cage is holding the whole thing together from inside. Weight is the force multiplier that makes every other advantage compound. A loaded Jeepspeed Class 1700 Cherokee weighs roughly 3,200 pounds with driver, co-driver, and fuel. A trophy truck rolls in at 5,500 to 6,000. Force equals mass times acceleration. At 70 miles per hour over the same set of whoops, the Cherokee generates roughly half the impact force on every component. The shocks run cooler because they're damping less energy. The axle housings absorb less punishment per hit. The tires survive more miles. The leaf springs and coil springs fatigue slower. The unibody cracks less per impact. Every single system benefits from the simple arithmetic of weighing less. Castang understood this in 1978. He wasn't thinking about the Baja 1000. He was thinking about fuel economy mandates. But physics doesn't care about your intentions. Light is right. Whether you're racing at Le Mans or crawling through Baja silt beds or just trying to keep a dying car company solvent. The consequences rippled outward in ways nobody predicted. Jeepspeed didn't just create a racing class, it built an ecosystem. The XJ aftermarket exploded with desert-specific components. Curry Enterprises developed race-spec 9-inch rear housings for the Cherokee. Deaver Springs built Jeepspeed-specific leaf packs tuned for high-speed desert frequencies. T&J Performance refined Crate 4.0 motors that survived 1,000 continuous miles on pump gasoline. King Shocks, Bilstein, and Fox all developed shock packages for the platform. Dozens of fabricators built cage kits, long arm conversions, fiberglass fenders, and fuel cell mounting systems. The series expanded from 1 class to 4. 1,700 stayed the stock class. 2,700 allowed stroker engines, turbochargers, and 35-inch tires. 3,700 opened up to any production engine and 37-inch rubber. 4,700 permitted tube-frame Jeep-shaped vehicles. Each level moved further from stock, but 1,700 remained the heart of the series. The class where a college kid with a welder and a junkyard Cherokee could line up next to a veteran racer and compete on equal terms. The cultural impact spread far beyond the race course. The Cherokee XJ became the default platform for desert exploration, overlanding, and pre-running across the entire American Southwest and Baja Peninsula. Every characteristic that made it competitive in racing, lightweight unibody, unkillable engine, simple drivetrain, enormous aftermarket support, also made it the ideal vehicle for anyone who wanted to run the same terrain as the race trucks without spending race truck money. Justin Weich found a Cherokee sitting in a field with a blown head gasket. He paid $500 for it, put coolant in it, and drove it home. Over the next decade, through hundreds of hours of fabrication and testing, he transformed that field rescue Jeep into one of the most capable desert Cherokees in the country. Custom 4-link front suspension, 12.5 inches of wheel travel from a modified Dana 32-wheel drive beam axle, 35-inch Dick Chapek tires on Walker Evans wheels, King coilovers and bypass shocks tuned through countless desert sessions until the damping was dialed to perfection. Videos show his Cherokee running through high-speed whoops, keeping pace with trucks running 40-inch tires and 20-plus inches of travel. A $500 field Jeep, hanging with vehicles that cost 50 times as much. In 2024, the NRT Autosports team ran their Jeepspeed specification Cherokee through the Nora Mexican 1000. 1,372 miles of Baja terrain over 7 days of racing. They won their class. Over 1,300 miles, and the Cherokee survived everything the peninsula threw at it. Chris Nisley, a longtime Jeepspeed competitor, once took a hiatus from racing. He pulled the race equipment off his Cherokee, reinstalled the windows and street-legal components, and drove it to work as a daily commuter for several years. When his business became successful enough to fund racing again, he pulled the windows back out, bolted the cage and race equipment on, and returned to the desert. Try doing that with a trophy truck. The Cherokee XJ went out of production on June 22, 2001. The last one built in Toledo, Ohio, was a black Cherokee Sport. The section of the assembly plant that produced them was demolished afterward. In 18 years, 2,884,172 rolled off the line. Chrysler killed the platform not because it failed commercially, not because buyers didn't want it, but because a cost-cutting executive named Wolfgang Bernhard, freshly imported from Mercedes-Benz and nicknamed the Whirlwind, decided the aging Cherokee was one of the first things to go. The accountants won, as they always eventually do. But the Cherokee refused to cooperate with its own obituary. Tens of thousands remain on roads, trails, and desert race courses more than 2 decades after the last one was built. Parts are still readily available. Online forums contain what might be the deepest technical knowledge archive of any single vehicle platform in existence. The community is self-sustaining and fiercely dedicated. You can still buy a running Cherokee for a couple $1,000s, and for the cost of a modest family vacation. You can turn it into something that will embarrass vehicles costing 20 times as much in the most demanding conditions on the continent. Here's what I keep coming back to. The Jeep Cherokee XJ was designed by a dying car company that couldn't afford to do things the conventional way. They made it lighter because they couldn't afford a bigger engine. They made it simpler because they couldn't afford complexity. They made it tougher per pound because they didn't have enough pounds to work with. Every single constraint forced a better decision. And 4 decades later, those constraint-driven decisions are still outperforming vehicles that had unlimited budgets and zero limitations. The trophy trucks will always outrun a Cherokee on the straights and clear every jump higher. But when the sun goes down over the Sea of Cortez and the silt rises up and the rocks start breaking expensive things, the Cherokee keeps going. Not because it's better in any measurable category, because it was built by people who had to survive with less. And it turns out in the desert, less is enough. And there you have it. A junkyard Jeep racing 1,000 miles through Baja against machines that cost more than most houses. If you've built one, raced one, or just beat one to death on a fire road somewhere, drop it in the comments. And if you made it this far, go ahead and subscribe. We do this every week.